Hello class, this is a video tutorial on cubic functions part 2. In this video we'll be looking at the general form of cubic functions. All cubic functions are of the form f of x equals ax cubed plus bx squared plus cx plus d, and when we factorize this we get this expression where p, q, and r are the roots of the function. So here's just a rudimentary drawing, not to scale, of the function f of x. It still has that general shape like this, except now it has three roots at p, whatever that value is, q, and r, whatever those values might be. If ever we had repeated roots such as this, x minus q squared, what happens then is the function only touches the x-axis and goes from there. So let's get to some examples. Determine the roots of the following and sketch the function. Well, like we do in finding the roots, or they're also known as zeros, we just let the entire expression equal 0. So plus 3, let all of that equal 0. Well, then now we have x plus 3 equals 0, x equals negative 3, x minus 1 is equal to 0, x equals 1, x minus 2 is equal to 0, so x equals positive 2. So from this we can draw a very rough sketch of what this function might look like. Obviously not to scale. There we are. While it's not to scale, it's best to keep it somewhat to scale. So let's say if this was negative 3, sorry, positive 1, positive 2 should be here, because 3 is about the same distance from the left and the right. So if that's 3, that's negative 3, which means 1 and 2 should be there. So graphing this should go through negative 3, go through positive 1, have a turning point somewhere in between, and there we are. So that's negative 3, 1, and 2. Obviously this is not an accurate depiction of what this function might look like. It's just a mere quick sketch. So let's do the next example. Here we are. So once again we let the expression cubed equals 0, so 3x squared minus 4x equals 0. Factoring this, take x on the outside. Further factoring this bracket here, this will give us plus 1, negative 4. Does that work? 1 take away 4 is negative 3. Yep, that's working. Which means now we have these three different roots. X is equal to 0, x plus 1 is equal to 0, and x minus 4 is equal to 0, x equals to 4. Doing a quick sketch of what this might look like as well. Obviously, once again, not to scale. Negative 1, let's say, is here. 0 and 4. So here's my negative 1, 0, and 4. There we are. Let's do two more examples of where this might be used. So here we are again. This one we once again let this equal 0. Let's factorize it straight away. So we get x on the outside, x squared minus 4x plus 2 is equal to 0. Interesting. Oh, sorry, I remember writing this question. This should have been 4 as well. That should have been 4. Should have been 4. Let's say it is 4. From here we can factorize this to become x minus 2, x minus 2, which will give us this expression squared is equal to 0. So now we can let this first factor equal 0. We let the next factor also equal 0, which give us positive 2. So in this instance we only have 2 roots, which means the function should look like as follows. So I touched on it briefly in the description above, that when there are only, well, if there are repeating roots, the function only touches the x-axis. So we have a root at 0 and 2. The function will move up like this, and when it gets to this repeating root, it touches the function and goes back up away from it. So I hope that gave you an insight into using the roots of a cubic to sketch a function. In the next video, I'll just go through different examples of using the properties of roots and cubic functions. Hope to see you in the next video. Best of luck.